Okay, so let's talk about homeostasis, excretion, and osmoregulation. Like I told you yesterday, this topic is wide because it's 3 in 1, but we are going to look at each and we see how it connects to the others. So we shall start with homeostasis, like I promised you, and try to see the principles, the mechanism, and how it is important in our bodies. So without wasting any minute, I want us to start with homeostasis for today and then see what we shall have for tomorrow. So with homeostasis, we are going to encounter a few things like this. We have our bodies made up of cells, like we agreed that cells form the tissues form the organs make up the organ system, and then the organ system makes up what we call an organism. But we have a number of things that take place in our bodies. Our body is filled with fluids. The cells are being bathed by the fluid, which you are going to see, and we have a number of changes that take place. The live example here is temperature. Of course, we have what we call body temperature, and it keeps on varying, but you find that it is not you who say now, oh, I want 32, take me to 38 or 37. Oh, I want this one, it is too cold, please come here. No, it doesn't happen that way. It is a system inside the body that keeps on making these alterations to make sure that at least this temperature is in a given range that is at least acceptable. We have ions in the body, transmission of impulse. We have these other components of blood and other things there that keep on changing. So those things keep on being detected and then changed in a simple cycle that we shall call a loop, and all those ones, when you sum them up, they form what you call homeostasis. So in homeostasis, we are simply going to look at the process by which the internal environment is maintained constant, simply because we have a number of things that keep on changing, or we have different stimuli. So we shall make sure, the body makes sure that everything is in a normal range. In simple terms, the moment you start examining the inside bit of your body, that is anything that surrounds a cell, because we said a cell is the basic unit of life. So anything that surrounds a cell is going to qualify to be called an internal environment, and basically it is fluidy. It is made up of fluids. If it can surround the cells or even the tissues, and that's why we shall see the concept of tissue fluid coming in. So the maintenance of the physical and then the chemical conditions of the internal environment constant is simply what we are trying to call homeostasis, or the maintenance of the internal environment constant, simply. So tissue fluid, I've said it is the fluid that is surrounding those tissues inside the body, and therefore they will need to those tissues will need to have a favorable environment in which they can easily work. So the body does all what it can to make sure that at least the internal environment is okay. If there are ions that we need in the body has to regulate. If it is temperature, you shouldn't be too hot and you shouldn't be too cold. So it has to make sure that at least a given range is maintained. So the process by which the body does all those activities to make sure that everything is at the norm qualifies to be called homeostasis. So that is homeostasis simply, and we are basically going to look at a few things that make up this homeostasis, basically the feedback mechanism. So we shall need to look at the feedback mechanism, we understand it to the best, and see how the body uses it to make sure that everything is in full control. There is another picture here, you can see homeostasis. So in homeostasis, we have a few things that take place. One, it is the stimulus from the environment that is sensed maybe by, let me say, the brain. So information is transmitted and then interpreted. After interpretation, it is taken to the effectors, for example the muscles, and then we have a response being generated. Like here, I believe here it was, if I'm not mistaken, this is a fan. So this is a response actually. So we have a stimulus here, which is the increase in temperature, and it is being detected by this thermometer, and then the brain interprets. So as a result, information will be sent to the effectors, for example the skin, to do the sweating. And the moment you do sweating, that means you need to find ways of making sure that at least the heat is reduced. So you try to look for a fan around and say, oh man, it is too hot this side. So things of this kind, all these ones, all the activities that take place to make sure that at least the internal environment, the inside of your body is in the good state, is what we are going to call homeostasis, as we are going to see here. So homeostasis is basically based on one principle, that is the feedback mechanism system, or the feedback mechanism that is set in place to make sure that everything is in the normal state. So this is the principle upon which homeostasis takes place. So we shall need to understand what is feedback mechanism. But at least from the literal meaning, feedback is like information that is given in return or as a result. So we are going to understand the feedback mechanism, and we are saying that feedback mechanism, it is just all that you're seeing here is a loop, but I just want to explain the feedback mechanism briefly. So a feedback mechanism is simply that mechanism which involves the detection of the stimulus, interpretation, and then carrying out of a response. So that is a feedback. So in feedback, you expect to get information at the end. So like here, we see that we have maybe a change in the environment, that is the stimulus, which causes these receptors. So the stimulus is an imbalance or any change that happens. So we have this stimulus being detected by the receptors or the receivers. After receiving, they take information to the control center, maybe the brain interprets and then tells the muscles, please contract. And after contracting, that's the stimulus or the change in the environment is being brought back to the norm. So that system in which we have detection, control, and then correction of the response is what we are trying to call the feedback mechanism. But we are going to divide feedback mechanism into two, and then see, one will have to be contradicting, and then the other one will be in terms with what we are trying to explain. So that is the feedback mechanism or the feedback system. So the question would be, what are the components of a feedback mechanism system? A feedback mechanism system is made up of 1, 2, 3, 4, 5. Some books write 4, others 3. Those who write 3 are, 1, that system must have receptors, control, and then effectors. They take these ones to be serious, but at least when you read other sources, you find that a feedback mechanism system is made up of these 5. 1 is the stimulus, as we saw. So a stimulus is an imbalance or any change in environment that is going to be detected by these receptors or detectors. For example, changing temperature is a stimulus. Changing the concentration of ions is a stimulus. Pain is a stimulus, and others that you can think of. A receptor is an organ that is capable of detecting the change in environment, which we are trying to call the stimulus. For example, the receptors that are in your skin, the moment it is too hot, you can feel, oh, when somebody pinches you, you can say, oh, I'm feeling the pain. So that means that the pain receptors or the heat receptors or the thermoreceptors have detected the change in the environment, and what they do is to transport the information to the control center, or what you call the regulator. So this control center, which in humans we call the brain or the central nervous system, is where all the activities are going to take place. So this is where information is understood. So these receptors just receive, but they can't do anything. So they can't transduce. So what they do, they get this information, transport it to the control center. The control center does the interpretation, says, oh, this is heat. Oh, now if you're heat, so let me tell these muscles to contract. Or let me tell the erector pili, this hair to raise, so that you don't lose a lot. So in the control center, we have interpretation of the information that has been received by these receptors, and then after controlling or after regulating, information is transported to the effectors. So these effectors are the ones that are going to carry out the response. For example, the muscles, when you've stepped on the nail, that is the stimulus, you feel the pain. So the pain receptors will of course have to transport the information to the control center, and then the brain will interpret and say, oh, it is too much this side. So what it does says you contract. So the moment you start contracting, you will of course have to withdraw the hand and then say, oh, it is too much. So you remove your hand. And then all these ones, the cycle that moves from stimulus receptor to control center, effector, up to when a response is produced, the whole of that cycle is what we are calling a feedback loop. As simple as that. So the summary is here. So we have a stimulus, for example, body temperature. In case body temperature exceeds 37 degrees Celsius, so that is a stimulus or a change in the environment. What happens? We have the sensors, what we are trying to call the receptors. Receptors come from receive or funa, so those organs that receive the information. For example, the nerve cells in skin and brain. So those nerve cells are the ones that are going to detect that change in temperature. So after the sensors getting this information, they will transport it to the control center or the regulator. That is, so we are comparing these two. That is the temperature regulatory center in the brain. So in the brain there are so many centers, each center working on a specific condition that has been brought. So control center, for example, the temperature regulatory center in the brain, of course they will start interpreting and then say, so here it was body temperature exceeding 37, so meaning that it is exceeding the normal temperature. So that means that after control center carrying out its work, it will send information to the effectors, say, you effectors, you sweat glands, please you start sweating, start producing some sweat, so that some water is lost, and then most of the heat is lost in the water that you're going to lose. So we shall have the brain instructing these sweat glands to start releasing sweat to make sure that at least water is lost, and we know that heat in human being is lost through the water. So you'll find that after these sweat glands being activated to release the sweat, the body temperature starts cooling. So that means you are taking it back to the normal. So all these activities from one to another up to when we have a correct response being got is what we are trying to call a feedback loop, and all these ones fall under what we call a feedback mechanism. So it is feedback simply because we have a change that is detected, and then a feedback is like the result that is got. So this is how homeostasis works, and so we call it the principle of homeostasis, which is a feedback mechanism. But let's understand the feedback mechanism system well. It is divided into two. One is positive feedback, and the second one is negative feedback. Now, when you hear these words, positive feedback and negative feedback, you say, positive feedback, wow, this is the feedback that is positive or that is good, and negative is the one that is bad. No. I don't know why scientists keep on confusing the English people. To our knowledge, we know that positive is good and negative is bad. But the reverse is true. Even when you go to the hospital and you want to check for HIV, you want to know your status. So they may give you positive. If you are naive enough, you say, oh, I have protected myself. You even start recalling the people you met and say, hey, they used to tell me that that girl had AIDS, but I'm now okay. Because you're seeing the positive, no, you'll be finished. Positive, that means you're sacked. So positive in biology tends to confuse. So with positive, we even see the reverse. And negative, which we would have seen as the bad, again, we see something that is good. So that is positive and then negative feedback. So we are going to understand only these two in the meantime, and then in our next meeting, we shall need to discuss these other things after the positive and then negative feedback. So we have positive feedback and then negative feedback. Let's go. With positive feedback, remember I said in feedback mechanism, we have a stimulus. That stimulus, which is like change in the environment that causes the body to respond. We expect the response of the body, or we expect a response that brings back something to the norm, like we saw for temperature. When temperature has increased, the body fought so much to make sure that it comes back to the norm. It is the reverse here. So now you can see how the positive is doing. So in positive feedback, if we have a deviation from the norm or from the set point, positive feedback does this. It makes sure that if there is a deviation, it just goes further. If it is pain, you continue feeling pain. So with positive feedback, to make sure that you feel the intensity of the stimulus that is in the environment. However, it is good, we see it here in the pregnant ladies, especially when they are going to give birth. I think those ones are called expectant mothers. So what happens? So we say that in positive feedback, this is where the deviation about the set point or a norm in any system will set in motion a sequence of events which increases the levels of substances or of that particular parameter even further. So this one, positive feedback, just worsens the situation. So let's see, where do we have positive feedback? As we are going to see, these pregnant mothers, the moment we have oxytocin being produced, its secretion into blood will cause the smooth muscles to contract, and then they will further bring the production of more oxytocin. So we have more pain that is being experienced, and then at the end of the day you'll have to give birth. So it is important in this way. Let's just look at a few things where we find positive feedback. This is an example. We say that we have a stimulus, receptor, control center, effector. So response enhances or increases the stimulus. The system gets even further from homeostasis or from the set point. But I'm interested in the examples here. Examples of positive feedback. One, we have propagation of nerve impulses. So in the propagation of nerve impulses, we have rapid diffusion of sodium ions into the neuron, which causes the positive voltage across the membrane. We expect the sodium gas to close, but here again we see that we have an influx of more sodium ions, which would not have been the case, but we have an influx, and hence we have an impulse being transmitted at the end of the day. The other one is production of oxytocin in labor, or when these ladies have gone to give birth, where we have a small amount of oxytocin which is being secreted into blood, and then causes the walls of the endometrium to contract. Remember, when you contract, that means that you're going to be pushing. So the production of this small amount of oxytocin, which is now the stimulus, is going to be enhanced or to be increased to make sure that again more oxytocin is produced, and then we shall have the endometrium walls being strengthened to make sure that at least the baby is pushed out. So we have more oxytocin causing this woman to have that strength to push the baby out of her system. And then the other one is increase in temperature. When the temperatures are too high, we have that 10-degree rise in temperature. I think that we call that one temperature coefficient, something of the kind. So instead of the body reducing, it further increases its temperature by 10 degrees Celsius. That is positive feedback. So with positive feedback, we have the situation just worsening, but of course it is important. So negative feedback does the opposite. Actually, negative feedback explains what we were talking about at first. If you have an increase in temperature, the body detects and then reduces. If you have a decrease, the body detects and then increases to make sure that at least it meets the norm. As simple as that. That is negative. So negative brings about good results, or what I will call positive results. And then negative positive feedback just worsens the situation. So in negative feedback, for example, of course we have the stimulus, receptor, the communication pathway, effector, and then the response. So what happens? We have a receptor here. Allow me to pick a pen. We have a receptor here. Okay, it is here. The conditions are always optimum. So the moment we have a change away from the optimum, for example temperature, the receptors are going to detect this change, and after detecting the change, we shall have the communication. These effectors, rather the receptors, are going to detect this change in the environment or in the condition, and then they will send information to the system or to the control center, which control center is going to interpret the information. It will be sent to the receptors, and then the effectors, and then these effectors are going to act accordingly to make sure that at least that condition is returned to the norm. Okay, where is my rubber here? To make sure that at least the conditions are returned to the norm. So we have return to optimal conditions in negative feedback. Examples of negative feedback. Body temperature. You have an increase in body temperature, so this one reduces. Rather, the body makes sure that you return to the norm. Or you do sweating. If it is increased, the body puts in some mechanism to make sure that it reduces. If it is reducing, the body makes sure that at least you return to the norm. Regulation of pH. We have osmotic pressure. We have hormone levels in blood, levels of carbon dioxide,